Hi guys. So in this video I'm going to show you how to move the frog. That's what I implemented so far, and you're gonna see how to move the frog, rotate the frog, and also how to change the frog, the image, the frames, so you can create a small animation like it's hopping when it's moving. And so let's see, or let me show you how the game is at this moment. So this is the game as I have it on this moment. So you have the frog at the starting position, you can move it around the screen. I've already added the limits, so you cannot move more down than this. You cannot exit the screen on the left, not on the right. And also at the top, you have collisions with these walls, but you can enter the houses. I call these houses. They don't seem like a house, and it's water like the rest of this, but they call it houses. I don't know. But in the house I didn't. So right now you can come to the top of the screen. You can like pass through the house and come to the top, but I won't worry about this because as soon as the frog gets to this place, we'll just disable the frog and create add the image that the frog is inside the house, and the player will come back to the beginning. So I'm not worried about that. But this collision was really important to make with this wall, and it is working. So let me show you how to do all this. So this is what we had at the last time where we were working, and I'm gonna show you guys with the project, using the project that I already have. So I'm not gonna be creating a new one, so I'll probably just gonna show you how I did things and how you can do it, but I'm not gonna be making all the steps again. So the first thing uh, to make the frog move is, if you come to the frog, if you select the frog here on the dashboard, you come here to the actor types, you can select your frog, and in your frog, despite the appearance, this was the ones that we used the last time, and you can see that I already changed this, but I'll come back to this screen in a moment. But right now we are going to this tab here, the behaviors. And the behavior is basically where you can configure the logic for your entities or for your actors. Like the actual behaviors that I can do. In this case, I create a behavior called move. And one thing that maybe it's important to notice is that you have these two tabs, behaviors and events. And at least I think the difference between these two is that when you create a behavior, for example, I create this behavior move, you can see on the dashboard that you have actor behaviors, and the behavior appears here. You could also create here, I think, create new. You could also create a behavior from this screen. And the big difference is that when you create a behavior, you can assign that behavior to other actors, or I mean to one or more actors. Let's imagine that I create a behavior and then I can reuse that behavior to as many actors as I want. But if you go to the frog or to any actor, and if you create the logic here on this tab, on the events, I think that behavior and that logic, it's only assigned to this actor, so you cannot reuse it with others. In this case, I could probably just add the move here on the events because we won't be using this logic anywhere else. But I started using the behaviors because I didn't notice these events, and the events didn't like caught my attention. Like I wanted to add some logic to my frog, so when I look at the event I didn't think about it. I was like, okay, this is a behavior, so I'm going to create a behavior. But I think this is important to know. So when you create a behavior, you have this advantage that you are not only creating the behavior for what the actor, but you can reuse that behavior not only in actors, actually not only in actors, but you can see here add to scene, you can also add behaviors to your entire scene. So you can come here and you see that you also have like scene behaviors. So that's something that we'll probably use throughout the game for the game logic, for the proper scene logic. And this code right here, I'm not sure. I don't know what this code right here is. Maybe it's for the game. The game contains no logic. You have scenes and actors. Okay, I don't know what this one is, but we'll probably get to it on the next videos. So actor behaviors, I created this move behavior, And now let me show you what I've done with it. Oh, and before that, I want to show you something, because I came here to the behaviors on the frog, so I selected the frog, came here to behaviors, and I did add behavior. And you have from this game, because right now I have the move behavior, but you have also a library with a lot of behaviors already implemented. So you can see here you have controls, like some effects, some game behaviors. You can see like behaviors for the camera, for the grids, stuff like that. And on the controls, I saw this one, four-way movement, and I thought, okay, this is exactly what we want, because our frog can move all the four directions, up, down, left, and right. So I tried this behavior at first, and the only thing that you need to do is like add the behavior. You can just configure the controls, so up, down, left, and right. Then you can configure the speed and some other things like the animations. You could configure here the animations that we imported earlier. So up the idle, which is when the frog is facing up but stopped, and the up animation, so when the frog is moving up. You could configure all this here, but we don't need it at the moment. Let's just see how it works. And I'm gonna deactivate this behavior because I only want to move the frog using the four-way movement. And now if we test the game, this is something that I think, for example, in Scratch was a little bit better, because you could just like press run and it would immediately run the game, and you could see like the changes that you were making. Here you have like this small compile time, which is not a lot, I know, but it makes iteration a little bit slower. And also, a thing that really bothers me, I don't know, it's not a problem, but it bothers me, is that it does not refresh the game that you already had before. So each time you press test game, it's going to open a new tab with the new version of the game. So you keep closing the other one. I don't know, it's not a problem, but if you could just refresh, you press test game and it will appear here again. I don't know. So you have this, and this moves the frog on all four directions. And it's still working. Now, the problem here is that for this game exactly is not what we want, because what I want here is that the frog moves inside the grid that we have. So if you remember, we have this grid, I mean not this one, but this grid. We are using this grid of 32 by 32 pixels, and what I want is the frog to hop between the tiles in the grid. So each time I press the button, it's going to hop one tile inside the grid. And in this, using this four-way movement, it's more like a smooth movement. So if you press the key, it just moves with that speed that we defined. It just moves along in the direction that you are pressing. And it makes it really hard, because if you want to like get inside one of the houses, you need to stop the frog exactly to get inside the house. So if you stick to the grid, it's a lot easier to control the frog. And even like this, because you don't want to stop the frog like this. I mean, the frog is either on a lane or on the next area of the game, or it's inside the water or not. I mean, it's not here in the middle. So this is just to show you that you have like a lot of behaviors already implemented, but this is not exactly what we want. So I ended up adding my own behavior. And also you can see that they don't only give you the behavior already implemented, but you can also edit that behavior. And you can see this is all the this is all the code to create the behavior that we just saw. But as like I said before, we are not using this one, so I'm gonna remove, and I'm gonna activate this behavior again, because this is the one that we are going to use. But before we use the behavior, we need to do something that I just remembered now. That when we painted the tiles, a thing that I didn't notice at the time is that it automatically assigns a collision to each one of the tiles. So let's go to the main tab, and here on the tile set, let's select the environment. And if you select a single tile, you can see the collision bounds. And in your project, if you are where we left the last time, you're going to see that all the tiles that you have in your game are going to have assigned a square collision bounds. What this makes is that this detects the collision between the tile and the actors. So when I was doing this the first time, when I was trying to move the frog the first time, the frog wasn't able to move because all the tiles had the square collision bounds, and every time the frog tried to move, it was just colliding with the tiles that we painted before. So the first thing that we need to do is to come here and change these collision bounds. And so, for example, the water is going to have no collision. So we want the actors to just move through the tiles of water with no collision at all. This is like the let's call it the road, not the road because the road is like on the traffic, like the sidewalk. Maybe this is a sidewalk. I don't know. Let's call it the sidewalk. The sidewalk also has no collision at all, and then you have these other ones that these ones have a collision because let me show you. Okay, these ones that we are seeing here. Okay, this is this one here, and this one. These ones should have a collision, and we can even add a square collision because our frog is going to be here, so it doesn't matter if the collision is only this part or the entire image because the frog won't come from the top. So in this case, we can let these tiles have the collision with an entire square. So this one also is a square, this one also is a square, so these are all the top ones. But now a thing that you probably noticed when I was showing you is that these collisions won't work exactly with the way that we are moving the frog. But either way, it's a good practice to just let the collisions assign the proper collisions to each one of the tiles. So these ones are all square, this one is also a square, and these ones are the only ones that are a little bit different because we want our frog. You can see that the tile is this square right here. And if we add a square collision to this tile as well, the frog couldn't enter the house. So we need to add another collision that just defines the collision bounds on this painted area right here. And it's really cool because on the collision bound, you already have a lot of shapes that you can add to your tiles. So you can see we already have like a rect right collision bound that we can add to this frame. Let me see if I can add it. How can I add it? No, this is the image. It's here, I think. No, here. So you can see you can also change the position and the size of the rect. In this case, the rect is exactly half of the tile. But if you want the rect to be larger or smaller, you could also change it here. So in this case, it's perfect. Rect right, and this one would have a collision with the rect left. So this is the first thing that you probably need to do, and then we can start moving the frog, because otherwise the frog won't move. Now, this is the collision. One thing that I'm now thinking about this is that probably it would be a good idea when you import a new tile set for the default one of the collision bounds to be the no collisions at all. I don't know, I think it would make more sense instead of assigning the square. I'm not entirely sure because probably when we are painting, you are going to be painting like the background and you're going to have some walls. It's not everything is going to have a collision and only some of them won't have. It's exactly the opposite. At least I think so. But that's just something to keep in mind. And now the frog. Okay, we have like the default behavior here, the movement behavior. And so how did I create this one? I selected the frog, I came here to the behaviors, I did add behavior, and no, probably it wasn't from here. No, sorry, it wasn't from here. Yeah, this was a little bit strange, not for him, it's from the dashboard. I think you need to come to the dashboard. That's what it is. You need to come to the dashboard, select the actor behaviors. I'm gonna delete this one. Select the actor behaviors and then create a new behavior. That's the way to do it, because once again, this is not like a specific behavior for the frog. It's a more generic one. Either way, I mean, you could have this way to also add it inside the frog tab and not come all the way here to add the behavior and then assign it to the frog. But that's how it is designed. And now you have all these options. So the design mode is where you use the blocks to create behaviors. You can also just write code, and you have the freeform arbitrary code. Okay, this is not what we want because this cannot be attached to actors or scenes. What we want is a design mode because it's the mode that we are using where we have the blocks and we can just drag and drop the blocks and connect them together. And the behavior type is an actor behavior, only applies to actors. This one I'm going to call test so that we can create a new one. And you have a new behavior. If you come to the dashboard, you can see now that you have the move and the test. But if, for example, if you came to our frog, we only have the move. But now if we had add behavior, we would also have the test right here. But on the other way, we could also do something like you have the test, and on the test behavior, you can attach to an actor, and you can select the actor that you want to attach to. So this would be a new behavior. And now I'm going to go to the one that I already have implemented. And so how does the behaviors work? All the behaviors that you are implementing in Stencyl start with an event. So you need like what triggers the behavior. If we compare once again with Scratch, it would be like when the green flag is clicked, when the space key is pressed, those kind of events that you had in Scratch. You had a category called events. These are also the events that you have in Stencyl. Actually, in Stencyl we have more events than in Scratch, but the logic is the same. All the blocks need to start from an event. And you have a lot of events. You can see a lot of them right here. So the basic ones, you have these three, which are the basic events. And how these ones work is when creating, which is exactly what I have here, when created. This is an event that runs only once when the sprite is created. So when the game starts, and this sprite, not the sprite, when the actor. This runs once when the actor is created and only runs once. So it's like setting up the actor when at the beginning, when the actor is created. If you want to set some information, some data, you can do it here, and it only runs once. Then you have these other two, when drawing and when updating. These ones run in loop, so I'm going to create here. These ones run in loop. When drawing runs once per frame. Usually the game is running at 60 frames per second. Whatever you put here is going to be running in loop, being called 60 times per second. And here, when updating, it runs at every 0.10 milliseconds, if I'm not mistaken. Something like that. I think it runs 100 times per second. Yeah, I think it's something like that. So this is frame independent, and this is depending on the frames per second of your game. Something like that. But what you need to know is that both of these ones run in a loop. So whatever you put here, when you what you had in Scratch, the forever loop, this is how you do a forever loop in Stencyl, because you have flows. In the flow, you have the loops, and you have this while, and you could do something like while true to create a forever loop. But I tried it. But if you do something like this, the game will crash because you create an infinite loop, and the infinite loops here don't work as it is expected. I mean, in Scratch, it's something different. You create a forever loop, which is an infinite loop, but that's the way it is designed, like these ones, when drawing and when updating. But if you try to do something like this, it won't work. And so this is just to give you an overview of the basic events. I'm going to remove these ones. We don't need it. I ended up having this when created because I was using it for something else. I don't remember quite exactly what, but I left it here. But I ended up using another type of events, which is the events of input. So you have when something is pressed. And this is exactly what you want. When we press the up arrow, the frog is going to move up. When we press down, when we press left, when we press right. So this is the kind of event that I ended up using. So you can see when left is pressed. If you press here, you can choose control, and you can see that you have all the keys that you can use. So I just change left is pressed, right, up, and down. And here you have when the key is pressed or when the key is released. It depends on what you are trying to achieve. And then inside you create the code. So to move the frog, and I'm going to show, I'm going to just deconstruct, not the left, yeah, the left. The other one is harder to deconstruct. So initially, what I ended up doing is just trying to move the frog. So if you come here to the list of blocks that we have. You select the actors, you have like the position and the motion, and this is exactly what you want. But initially I went to the motion because we want to move the frog, so I went to the motion category. And you have a lot of things like with speed and velocity and force, so you have like a physics, working with the physics and stuff like that. But this is not exactly what you want. This is for the type of movement that we had earlier. Right? It's like a smooth movement. You just press and the actor will just move smoothly across the screen. And this is not what we want. What we want is when we press, the actor just jumps from, I don't know, jumps 32 pixels on 32 pixels to remain inside the grid. So I ended up not using the motion, but what I'm doing is I'm setting the position of the actor directly. So I'm saying, okay, when I press a certain button, in this case, when I press the left button, what I'm doing is that, okay, I'm changing the X position of the actor to be, to have a certain value. So you can see set X, you can choose X, Y, X center, Y center. So you know that X and Y, like I said before on the other video, the coordinate system here, I'm not going to call it the center, but the X and the Y, the coordinates of each actor and the scene and everything, it's on the top left corner. So when you are using a sprite, let me just get a sprite here. So when we have this sprite, when we are assigning or setting the X and the Y position, we are talking about this corner right here. While in Scratch it was in the center. In this case, it's on the top left corner. But you can also change, instead of being the X and Y, you have the X center and the Y center. And if you choose this one, you are not working with this position right here, but exactly in the center of the actor. And you have these two other ones that I don't know what they are. X on screen and Y on screen. I don't know exactly what they are. I needed to check these ones, but probably we'll get to that in some other videos. So what I'm doing is that I'm setting the X position of the frog to a certain value. And how am I getting this value? So what I'm doing with this value, you can see that I have a lot of stuff here. So first, what are we doing is that if we have the frog here, when I press left, what do I want? I want the position at the X position of the frog to be exactly the same as it has right now, minus the offset that we want to move. So in this case, the offset is 32. Actually, I didn't do it 32. I actually changed it, but initially it was 32. But so I want the position to be equal to the X position of the frog minus the offset that we want. So it just jumps here and then jumps here and then jumps here and so forth. So what I'm doing is exactly that. So I'm doing a subtraction. I cannot zoom these ones. No, okay. So I'm doing a subtraction of the X position of self, and self in this case is the actor where the behavior is attached. So I'm using the position of the self minus the offset. And the offset is something that I create. You can see, like, you could also put the value here, like 16 or 32, for example. But that's initially what I did. But the problem is that we are going to be duplicating this code in all these 4 events, like up, down, left, and right. And I didn't want to write this value on all these events, because if I wanted to change the value, which happened, I needed to change in all of the blocks. So I ended up creating what they call an attribute, which is a variable. I ended up creating an attribute called offset, and I'm using the offset everywhere. And then if I change the value of the offset, it's going to update in everywhere where offset is used. And how do you create a variable? In this case, they don't call it variables, they call it attributes. So you have it here on beside the palette, you have it here, attributes, and you can see that you can add attributes. So when you add an attribute, and you can see an attribute like a variable, so something that you use, that you give a name, and where you can store some value in it. In this case, we are storing a number. So I'm going to create like test, and you can see that you can create attributes with all these types, which is a major improve from Scratch, because in Scratch you can only create variables, text variables. Text and not text variables, numbers with numbers. Here you can create variables with a lot of types, and in this case it's a really basic one, which is a number variable, and you give it a name, and you can also select it if it's hidden or not. And this is really cool because you can create attributes that are shown on the behavior configuration, and I'm going to show it in a minute. So I create a new attribute called test, and I can use it now here on the code. So if you come here and you have, what is it? Proper. Oh. Attributes here. Attributes, you can see that you have number getters, offset, and test. Set getter is maybe they call it getter, and setter is something from actual code. A getter is something that gives you access to the value of the variable. So it gets the variable, the value of the variable, and a setter is a way to set the value of the variable. So when you do getter offset, it's going to give me the number that's inside the offset, and a setter, you can see that I can set offset to a certain number. So I'm setting the value on the variable. And I was going to show you if it's hidden or not. So let me see. It should appear here, no? Edit behavior. Maybe because we are not using. But basically, when you don't hide the attribute, it's going to appear here on the configuration page of the behavior, which is really cool because, like I said before, you can reuse the behavior. I mean, assign the behavior to different actors in your game, and you can also make that behavior like configurable for each actor. So you can I could add this behavior to this actor, and if I have like some public attributes here, I can change the values, and this behavior will work differently or with different values than from other actors that are also using the behavior, which is a really cool feature. Like you can see it here. When we were applying this one, you can see all these attributes that you have here. These are all public attributes. And so I can add a four-way movement to my frog and choose the controls, or choose use controls or not, or stop turning or something like that. And then I could use this four-way movement to another actor and choose different values for these attributes, which is a really powerful thing here in Stencyl. But in this case, it's not appearing, probably because I'm not using it. I don't know. But either way, we don't want our attributes. I'm going to remove this one here. On the offset, the offset is hidden because I don't want to like change the offset from the outside. Actually, we are not using this behavior anywhere else, so it doesn't matter. But either way, in code, not only in Stencyl, but in code, good practice to have is that everything is private until you have a good reason for it to be public. And what I mean by this is that when you have an attribute that is public, which means that if it's public, it means that it is exposed to the rest of your program. It means that someone can be using that value, or someone can be setting that value, changing that value. It makes it more difficult to debug your program if you don't know because you don't know where that value is being used or who is changing that value because it's public. But when it's private, in this case hidden, it means that this attribute is only being used and changed inside this behavior. So it's a lot more contained and a lot more easy to debug when you have a problem with it. So, and this works for all languages everywhere. Everything should be private by default and only public when you really have a good reason to create it public. So just keep this in mind. And so I created an offset and I gave it a default value of 32. Actually, I think it was 16. No, 32 because we are starting in the middle. Yeah, I give it a default value of 32 because it is the size of our grid. And so what I'm doing here is that I'm setting the X position of our actor to its current X position minus 32. And this is going to work every time we press the left key. So I'm gonna get to this in just a moment. Let me just see. Yeah, I have all this. Okay, so now if I press left, you can see that it's moving. But now I'm not limiting the movement when it gets to the side of the screen because I removed that I already had, but you can see that it moves left. And this is basically what we do with the movement, and we need to do this. And why, just before I continue, why are we doing minus the value? Because remember that in Stencyl, the coordinate 0, 0, the origin of our scene is on the top left corner, which means that, let me show you here, Okay, this is our scene. So our scene is 448 by 512, which means that the coordinate here is 0, 0, and the coordinate here is 448 by 512. That means that to move left, we need to decrease the x position. So this is the x here is 0 and the x here is 448. So we need to decrease to move left and increase to move right. And in terms of the y position, we need to decrease to move up and increase the y position to move down. So this is why the coordinate system is so important to understand right from the beginning. And all the other events is exactly the same, but instead of left, we change to right, up and down. And instead of, for example, to move right is exactly the same, x to x plus the offset. And the up and down is we change to the y, so set y to y minus offset or y plus the offset. So this is the basic code to just move the frog around. And so now that we can change, we can move the frog, let's just deal with the animations. That's something also really important to make. So let me see. Okay, we can come here to the frog, to the appearance. That's where we have our animations. And I changed a lot here. I have no idea why, but on the other video, when I was creating this for the first time, I ended up doing this. So I created the animations for going up, left, down, and right. And I have no idea why, because I'm not using these ones, because I can just use these ones and just rotate the sprite to the direction that I want. I was not thinking straight. So I have no idea why I did this. I have no idea why I imported everything here. I was not thinking about it in the correct way. So you only need the frames, like the idle frame up and the idle frame moving. And then what we are going to do is only using these frames. And when we are moving to a different direction, we are just going to rotate the sprite accordingly. And the other thing that I also did is that I added all the animations with the frames. So the idle frame and the moving frame and stuff like that. And we had like the looping option also selected, which is by default. And so when we added all this the first time, you could see that the frog, despite being idle, despite being stopped, it was just like playing the animation on loop, which is really strange. So what I ended up doing is that we have an idle animation, which is just an animation with one frame where the frog is stopped. And this is the default one, because you can see like this star here sets as a default animation, which means that this is the animation that the actor will start with. And then I created a new animation called move, which has also, maybe I don't need this frame. Wait, now that I think about it, I don't need this frame. Yeah, because when we call the move, so the frog is idle. When we press the key, what we are going to say to the frog is, okay, now play the animation move. And in this case, I added also the idle frame at the end, so I don't need to come back to say to the frog, okay, play the animation move, wait for the animation to stop, and then go back to the animation idle. No, I don't need to do it, because I say that the animation doesn't loop, so it only plays once. And we press the button, it plays the animation, so the frog hops and goes back to idle and just stops. When you press another button, it changes again to this animation, goes back to the frame 0 and plays it again. And so it works this way. Actually, let me just see if I didn't break anything when I removed the first frame. I don't think so. Yeah, perfect. No, not the left. Yeah, the left is not working because I removed the code. It's even better than I had before. That was the mistake, because it looked before it looked like the frog had a small delay with the animation when I was pressing, and that was because I had the idle frame again at the start of this animation. So the frame would be idle, and I would press, and then it would play idle again, hop, and then idle. So this idle in the middle was giving a small delay with the movement, So it looks really strange, and now it's a lot better. Now it looks like it's properly hopping. Yeah, that's what I wanted. And so how can we do this in code? In code, we have all This I'm gonna leave later. So we have these three blocks here. The first thing that we need to do, not worrying about the animation right now, is rotating the sprite. So I'm gonna do it here. So you can see point, and this one is on the palette, actors, here, point. You have also this turn, but we cannot use turn here because you're gonna say, okay, turn 90 degrees or turn, I don't know how many degrees, but it is works when you are turning the frog one on to one side or the other one. And in this case, we don't want that. We want to, when we press a key, we just need to orient the sprite to the direction that we want. Because if we turn 90 degrees, then if we turn it right, it works okay. But then if I press left, I don't have a way to say it. Okay, now turn 180, and if I press up, just turn 90. It was way more difficult to make it using these turns block. So we have the point. And the point, the way it works is that, okay, 0 degrees is up, so you have 90 degrees, 180, and 270. Or the 270 is also minus 90. So when the frog is moving to the left, we point towards minus 90, which is also 270. And then we switch the animation to move. So we say to the frog, okay, now use the move animation, and we switch the frame to 0. And this we need to do because if we don't switch the frame to 0, it only plays only the first time that we move left, the animation will play, and then it will be at the end of the animation. And when we switch animation again, it won't start again from the beginning. So we switch animation and then switch the frame again to 0. And this here we are repeating the switch animation to move. We shouldn't be, we only need to do it one time because we are coming from the idle to the move. But since we have the idle and the move, we need to switch the first time. So I'm not worried about if we are repeating this code or not. But we are repeating the code without needing to repeat it. But that's not a problem. So point minus 90, move, and switch frame to 0. Right. The only difference is that you're going to point 90, up you're going to point 0, and down you're going to point 180. And that's basically it. And okay, now let's test the game. Yeah, I mean, it's not too long, the compiling process, but it could be faster. So now it's moving up, moving left, down, and right. That's exactly what you want. Now let me just try something here. Now I'm curious. If we don't have this idle animation, if I say that this one is the default one, and let me see if we see the animation running the first time, because if we don't see the animation running the first time, we don't even need to change the animation to move. Yeah, we don't see it. At least I think so. If we can refresh this. Oh yeah, you see. You see it plays the first time. Yeah, okay, no. Not convinced. Because I was just trying this, because if we didn't saw the animation playing the first time, then we could just have this animation and just switch the frame back to 0 every time we want the animation to play again. But since we see the animation playing the first time, we cannot use it, so we need the idle one. I mean, it's a really small detail, but either way, it makes a difference. Yeah, and now let me see. Yeah, now if we refresh, you can see that it's not happening. Okay. Okay, this is it about movement. I'm not gonna talk about the collisions on, because now we need to limit the movement of the frog here in the game, and we need to also deal with the houses on the top. So I'm gonna leave it to the next video. So this is it. Thank you guys.